Hello everyone, welcome back to the channel. I am yours Rahul. So in last videos I posted regarding basics of Java, then arrays, then sliding window method. So in today's video we are going with linked list, which is the singly linked list one, which is one of the important concept in DSA. So in most of the tech companies, like in product based companies, this question is must. This method thing. So they will ask other things rather than simply linked list. They will ask some other questions from linked list only, like doubly linked list, circular. That things will uh, mention in these weeks. So we can start with single linked list from today. So if you are new here, subscribe my channel for more coding contents and tech videos. Let's start. Okay. So, linked list. Actually, it's a sequence of nodes where each node stores data and we will have a pointer or a reference to the next node. Just imagine a train. You might be see like it's have a head and it's have a tail part. Between that, so many compartments. Say, and each compartment will be connected with a chain, right? So same like that, we have list, linked list. Each have nodes and each will be connected with a pointer or a reference to the next node. So you might be think like if there is no other data at last, then what will do? At that point, when there is no data at the end, we have to point to null. Okay, so I will just show you. Just think this is the first node. Okay, and it will point to null as of now. Okay, I'll just okay. Now we have the data one and it will point to null. Fine. So if there is another data, next data is there, then how it will be? Then it's nothing but we have our data 2 and this. mm, okay, will go to null. Understand? This is the way that linked list work, which means if there is no data, then our head will point to null, and if it is other data, and the end it will point to null. This is the pattern. So it can be used when we have we need a dynamic size and we need frequent insertion or deletion, especially at the end, because as I mentioned, we can in a single linked list we can insert data at the end. Okay, uh, in a faster manner, and the operations that mostly do in linked list are insert last, then display, then delete by value. So these are the most common used operation in linked list. So uh, this is the starting point regarding linked list. The idea like we have a data, we have a pointer to the next node. So we can start with a coding session which will show these operation, which will you will get understand furthermore what and why we using these and all. Okay, so we have the main method. Now we need to create one class uh, which is the building block. So I will name it as node static class node. Okay, so here the most important thing that we need is data, um, which means one variable to store the um, data. Another one which need to reference to the next node, which is meant by a pointer. That's it. Int data. Then okay. Now we can create a constructor which we could use later in our coding sessions. This dot data. Next. Fine. Sorry. Null. Okay. Because initially we have to set in this way because if there is nothing to point, then we have to put it as null. So that's it. This is the building block of linked list, which we have the data and the reference. Now we need another class in order to show these functionalities as I mentioned: insert last, display, delete by value, and all. So I will create one class linked list. So this one is singly linked list. Okay. Now first thing we need to uh, get the head point, which is head point to the first node, and if it is empty, then null we have to give. So node head. Okay. So first operation is the insert last. So public void insert last. So we have the data. Okay. First we need to create one new node. Node new node. You can give names as you wish. This for understanding only. Now we need to set like if the list empty, then we have to assign head the new node to head. head is null, then head is equal to new node. Okay, I will just show you what I meant. Uh, there is nothing now, right? No data, nothing. So as of now, I am just having a value. Okay, 2. Fine. And I want to insert in the linked list. As of now, what it's mentioned, we have a head which is null. Okay. Now we have the 2. So we will give the 2 here. So the 2 is here. Fine. And it will point to null. So this is the thing happens in this one. If the head is null, we have to assign the new node to head. Okay. Then we have to return. Fine. Now we will start from our head. Okay. So I am just creating one temporary variable um, in order to uh, assign new values. So when I use temp, it will be used as the pointer, not pointer. Actually, it's like mm, storing variables temporarily. Currently, I am storing the data from head to temp. Then I will go for the next data. While next not equal to null, then uh, which means we have to move until last node. If this condition is false, like if it is not null, if it is sorry, if it is null, then it will be the last element, like that it's given. So temp is equal to temp dot next, which means we will move forward. Now we have to link the last node to the new node, which is temp uh, sorry, fine. So this is the way we can insert the elements in linked list. Now we have to write one another method, that is the display, to display whatever we are storing in the linked list. So public void display. Here it's nothing. We have to start from the head only. Node temp is equal to head. Then the same condition while sorry, uh, temp is not null, Then we have to, which means we have to traverse until the end. System dot out println dot data. Now I will just give the way that pointers assigning. So after this, we have to um, go forward, which means we have to point to the next node. Fine. So once this done, uh, we have to give another print which indicate the end. Once we traverse the list. Okay, fine. Now we are going for another method which is the delete by value. So this method actually delete the first occurrence of a value. Okay. First of all, the thing that are in deletion we have to check is it a empty list or not? Because if it is empty, then there is no need that we have to go for traversal and all. Right. So in some lead code challenges, when you get a question like delete or remove a value, first thing that you have to give is you have to go for whether to check is it an empty list or not, because in some test case they will give empty ones which will you might miss in that sections. So the thing that we have to give int value. Okay, so first we are going with head is null, then nothing, just return. Then we are going with if uh, value is at the head only. If data is equal to value. Okay, then we have to move the head forward, which means uh, just think this is the one we need to delete. Okay, so what we will do, we will move this head. I forgot to mention this thing at the starting. Sorry for that. Okay. Okay, so at starting in where whatever in linked list, so we will point the head at the first element, then it will go. Sorry, it's actually the arrow is to the right. Okay, so now what we will do, if the value is one that we need to delete, then we have to point the head to here, then we have to delete this. Fine, this is the thing happens when the value is at the head only. So head is equal to or next, we will just move the head to the next one. So once this done, exit. Okay, now uh, if it is not even head, the if it is something, the value is inside somewhere, then we have to do the traversal. So we have to create one temporary one which is start from the head, while temp dot next not equal to null, and temp dot next dot data not equal to value. So what's this mean? This one, it will go till the end of the list, temp dot next dot data, which is not equal to value, which means I'm just removing this. Not yet. Okay, okay, okay. Just think in this way, and two, then three. Fine. Now what it's given, temp. Fine. So we have the temp, head is equal to temp, like that we given as of now. So what it's doing is it will just point, it will just check temp dot next is not equal to null, means if it is not null, then it will traverse till it find null. Now second condition, I will just copy this and okay. So this condition temp dot next dot data, so this one, temp dot next data is not equal to value. If it is the value, then it will just point the reference to next uh, data. For that one process, it is just given this condition, rather than going just a traversal, it gives another condition also. Okay, so in simple words, it's nothing but we have to find the node. before the one to delete. Temp is equal to dot next. If sorry, not equal to null, which means if found, then we have to unlink the node, which means we have to point it to the one that we have to delete to the next node, which means as I mentioned, if I want to delete 2, okay, 2, or I will just go with another one also so that it will be easy. 4, fine. So as of this, if I have to delete 3, then I have to point the temp of this temp dot next to the one that I have to delete dot next. So what will happen? It will remove, and this will point to 4. Understand? So this is the thing happens, which we will just unlink the node temp dot next is equal to temp dot next dot next. Just think in this way. I have to delete 3. So I can't just go and delete 3 in a normal way. So as a linked list, we have to point this 2 to the one that 3 is pointing. If it is null, we have to point to null. If it is another data, whatever, the 2 dot next is 3, dot next 4. So we are just pointing whatever it's pointing. That is, it means temp dot next is equal to next dot next. Okay, so that's this condition means. So we will just unlink this to 4, and this will just go. So this is the way we are deleting by value. Now we can give some values which we can see how it works and all. So linked list new linked list. Okay, so for the inserting nodes, insert last, then just copying this, then okay, 20, 30, 40, 50, 60, and 70. Fine. So now we can display how this is printing. So I will just system dot out dot println linked list. Okay. Now nothing but we are just calling the display method. We can just run this 10, 20, 30, 40, 50. Okay. At the last it's null. Now we can delete the next one, which we can check for the delete by value list dot delete by value. I will go for 30. Okay. Now what it will be? Okay, we can just comment this and check. See, 10, 20, 40, 50, 60, 70, null. So while writing the code, you may not understand what all this happening. That's why it just shows you what's the exact thing happening in linked list. How this pointers and all work. How the next pointer is connecting to the one that we need to delete, which points and all. So this is how single linked list works. So some common mistake that you people might do is like forgetting to update the head when we deleting the first node, then going for infinite loop, if you forget temp equal to temp dot next, then when inserting many items, we have to consider keeping a tail pointer which will make it the insert last with a complexity of big of 1. Fine. Another one method, which is the Floyd's method, is there, which will use to detect cycle in a linked list. Uh, Cycle means it's nothing. It's like mm, which means a cycle that exists if some node's next point to a previous node, which will forms a loop. Just think like here 50, 10, 20, 40, 50. Then again, if it's point to 20, that is a loop. Okay. So how Floyd's algorithm works in this linked list? That's the thing. So here, what it doing is it will use one slow and fast pointers, which will use in two steps. If they meet, then it's a cycle. So it is actually using to detect infinite loops in data structure for corrupted pointers. I will just show you what it means. Okay, fine. Mm, so as I mentioned, 10, 2, 3. Now if it's points to 1, then it's a loop. So this is what we are why we are using um, Floyd's algorithm. So we can start. So I will keep this node can. Okay. So insert last we will use. We can remove this. So um, list. We will create uh, the insert last method parameter into data. Now, like before, what we said, we will create a new node which points to the head if it's empty. Okay. If mm, oh, sorry, it didn't give head. Okay. If head equal to null, then we have to assign it to the newly node to head. Then exit. Now, if it is not, then we have to go. We have to do the traversal. Before that, we have to create the temporary one. Temp is equal to sorry head. So while next not equal to null, temp is equal to temp dot next, temp dot next is equal to new new node. Fine. Now we have to go for the fluid cycle detection. Okay. Public sorry. I am just creating one method with the name has cycle. Hmm, second, it's nothing but public boolean cycle. Okay. So here we need two pointers like one in a slow manner, another one for fast manner. So node slow is equal to head, node fast is equal to head. Okay. Now uh, we have to check whether the fast is not equal to null and the fast dot next also not equal to null in order to do the traversal. While fast not equal to null and fast dot next, which is the one that pointing also not null. Then we need to move one step. Slow is equal to slow dot next. Then we need to move two step for the first pointer dot next. Now we have to go for the meeting point. If it is a loop, then we have to give like if slow is equal to fast, then we have to return true, else return false. Okay. Uh, B. Now we can check a cycle. Okay. Now we need to find the last node to create a cycle manually. So here what we are doing is we will point the uh, tail to the second node which to form a cycle, while tail dot next null is equal to tail dot next. Now nothing, we are just pointing is equal to list dot head dot next. So before this we can just check false. Okay. After linking, now we can check. Yeah. Hmm, it's not working. Not add, add. Hmm, dot next. It's it is second. So the error should last. Okay. So we have to attach this at the end. So yeah, now it's working fine. So this was the error that found. It's not an error. It's like yeah, error only. So the complexity is big of n and the space big of 1 for this. And uh, this is the thing. Now we can go for one lead code problem. So here it's nothing but we have to reverse this list in backward, like as it mentioned 1 2 3 4 5 to 5 4 3 2 1. Okay. So when we are doing this, some things that we need to keep mind, like we need two pointers, which one uh, pointer which will always point to the head of the portion of the list which has already been reversed. At the start nothing is reversed, so our uh, one null sorry one pointer is first one is null. Next one which will walks to the original list, which means node by node. At any step it points to the node we are currently processing. Understand? So in that way we have to start list node uh, previous is equal to null. Then another one which is for the current. Right? Okay. So now we need to check one. We need to loop while the current is not equal to null, which means while there are nodes left to process, when current becomes null, we will exit the original list. Okay, while current not equal to null. So now we need to uh, save the mm, next. Next is equal to current dot next. Now we need to reverse the pointer, which means next is equal to previous. Then we have to move the previous forward. Then we have to move the current next. It's like a, somewhat just look like a swap only. Previous. Yeah, that's it. So this is one for linked list reversal. So I will just mention what these and all. So this previous pointer which points to the head of the portion of the list which is need to be reversed, which has already been reversed. And current will walk through the original list. So this one will used for the looping, which means for traversing. Then here it is used that the next node in the original list into a temporary variable. So here it's doing the reversal and all. So this is with respect to the question reverse linked list. In next video, we will go with the uh, doubly linked list and circular linked list and all. And I will give you a mini project which work with respect to the singly linked list, which is actually a to create one playlist. I will share the question also so that you can check what to do and all. But actually, it's a simple one. If you start trying on that, you can understand how it works and all. So just try to do that project work. If you have any doubt or if you stuck anywhere, just ping me. I will help you and I will just guide you what to do and how to fix that error and all. So see you in next video. Till that, happy coding.